I mean, even my 4-year-old son, well, he was 4 when this photo was taken, loves rockets. This is a tiny little Class C rocket, which is like one of these, and we were launching it in a park near our house. It had an Arduino-based telemetry package in it, so it was transmitting real-time data back from accelerometers to that laptop you see in the front, all in a rocket that's about this big. So that was pretty cool. So even Thomas loves rockets, and yet we didn't really have all that many people involved. And it's made me wonder a little bit. And I think part of the problem is that it just seems unrealistic to get involved in that sort of activity. I mean, we're not talking about little Class C stuff here. We're talking about the Lunar Numbat, Google Lunar X PRIZE type level of activity. When you start talking about, hey, we're going to have a mission where we put a remote control rover on the moon, people go, yeah, right. And it just doesn't seem like you can get involved. And this is one of the projects that we've just been working on, also as part of the Connected Community Hackerspace in Melbourne. This is the Arduino rocket telemetry and instrumentation system. So this is like a really super crude equivalent to Vidal and Keith's effort. But the idea with this was that it was to be very cheap and simple to assemble, and we could get up and running really easily and just do some really low-tech tests with it. So that was a rendered concept of what it was meant to look like, and the first handmade prototype actually looked like that. Not quite as neat, but it worked quite well. In fact, we flew that a couple of times. And, this was a launch we did it was December 29, so it was just before New Year's. So the white one you can see there is a little Class G rocket which is carrying the Artemis payload. To the right of it, you can probably barely see it, is a tiny little Class C, which is like one of these, which is carrying another payload, also based on an Arduino. And this was actually flown in an urban area. So we had to use special rocket motors that had a very short burn time, so we didn't exceed the altitude limit. Lee, once again, has been working on some image processing. And what he's done is come up with a method for compressing JPEG. So this comes from a motion JPEG video stream, extremely fast. So with very, very little CPU overhead, he's able to take a frame, so in this case 292K, and apply varying compression levels to it. And he can output a version at 2.2K, as you can see in the bottom right there, which obviously has a lot of image degradation, but it goes down to something like it's less than that, it's like 0.7% of the original image size in pretty close to real time. And that's really, really impressive.
Wouldn't it be like quicker and cheaper just to take the approach that the Americans did with the moon landing and fake it?
So I need to amend this list a little. What I need are special effects artists.
How are you dealing with the fact that, I mean, using commodity components for hacking on, how are those going to work in a rad-hard environment?
Okay, what we're doing at the moment is just prototyping the architecture, and the idea is to replace parts with radiation-hardened parts as we go. So we're still in the very early stages of coming up with proof-of-concept solutions, really, and the idea is to then iterate through to something that is flight-ready. Actually, on the subject of radiation-hardened, it reminds me of a little story. Those Lunar rovers that I showed you right at the start, one of the problems they knew they were going to face was because the lunar day and night are 14 days long, they couldn't keep them warm, and it goes very, very cold at night. And so to stop the lunar rovers freezing, they simply chucked some radioactive material in the middle of them. So those rovers are highly radioactive, which had the side effect that they had to make all of their electronics super hardened against radiation. And then many, many years later, when the Chernobyl disaster happened, they couldn't find anyone with the engineering experience to build robots to go in to do cleaning up. And they actually brought a couple of the Lunarcod engineers out of retirement. They dusted off the old Lunarcod plans and built variants of them to use as miniature remote control bulldozers. And they went into Chernobyl. They were pretty much the only things that could survive in the area. Paul?
Yeah, g'day. Just on the video compression, about, I think, 3 or 4 years ago, I saw a FPGA chip which was compressing 640 by 480 video down to OGG files at 60 frames a second. So, and as in, at faster than real time.
Yeah. Cool.
So I'll give you more details maybe later. But
Lee's the one that would like those details.
One of the biggest problems with that sort of thing is that sort of hardware, you just cannot get red hardened. They're talking about just shielding commodity hardware anyway, if they can get it to a stage where it will actually still work. The advantage of JPEG 2000 is we can compress the original images for high definition television level in real time in hardware. And then in software we can cut it down to those very small sizes very, very quickly with little processing power, and also avoid sending the data twice. So one of the cool things about JPEG 2000, you can just cut it off in the middle at a packet boundary within the frame, and just send the first bit now and the last bit later, and you get the whole high quality piece, which is actually a really helpful thing when you're bandwidth limited.
Yep.
And very long latency, obviously.
Yes.
And look, the radiation hardening thing is both a whole lot easier and a whole lot harder than you think. The whole lot easier part is that folks building stuff in the amateur satellite community have been dealing with this for decades, and we've flown a lot of stuff very successfully. And there's some fairly simple rules that you can follow for component selection that will help you to avoid picking things that are going to be particularly problematic. The potentially very difficult and frustrating part is that those rules will cause you to eliminate almost all modern, simple high integration microcontrollers. And so the notion that you can take, a PIC or an AVR or something, and without lots and lots of, thought about what the trade-offs and issues are, expect to fly something like that, you have to be, sanguine about the probability of that working. But the sort of, while there are lots of things we don't understand yet about the radiation environment of space, there's an awful lot that we do understand, and people have built and flown things using non-explicitly rad hard parts, and those things have gone on to have multiple decades of useful lifespan. So this is not nearly as crazy as you think it is, but it is tough because a lot of the parts you'd like to use,
you just can't.
You just can't because they won't work. They've got dynamic configuration cells, and they'll take high energy particle hits, and all of a sudden the bits have flipped and it doesn't work at all the way you thought it would. So.
Yeah, I think someone else had a question.
Yeah, my question is, it's more of a RF question. Have you considered using visual as opposed to RF when you're landing the vehicle?
For range finding?
Yeah.
I haven't been directly involved in that part of the decision process. Lee can answer that.
Doing it visually is not as accurate. There will be a down-facing camera to determine the movement relative perpendicular to the surface, so we can tell if we're moving across it. But vertically, which is the most critical dimension, has to be reasonably accurate. We're looking at about, I think it's 2 or 3%, down to about 2 meters, and from about 2 meter accuracy above 150. Which is close enough. The moon's gravity isn't that great. You can drop from 2 meters and not doing much damage. So there's definitely a camera, and that will actually be coming back in near real time as well.
What about the laptops they were using on the International Space Station, the Russian space station? They ran.
Pete else eager to answer that one.
I'm just wondering. I mean, they ran. So obviously it can't be that bad.
Yes, it is. Those are underneath the Van Allen belts. When you're on the moon, you're not. Zappity zap.